Deep Dive Networking 1. So, if you guys have ever taken a certification course and tried to study networking, you guys probably know how dreadfully boring this topic is going to be. And for those of you who haven't, this is not an exciting subject at all. So I'm going to try my best to make this exciting and educational and provide you guys with some information that you haven't considered before, but that may not happen. So whether or not this is valuable to you guys, you'll just have to let me know. That being said, let's dive into it. So networking is obviously a core part of IT and computers in general. And networking is important because this is how data flows between computers. This is how everybody connects to the internet. This is how everything is configured. And from a security perspective, knowing networking will help you understand how data can be manipulated and where threats can be sourced from. And in general, IT is a key part of your troubleshooting path, is knowing networking. And a lot of the information we're going to cover kind of will help you understand that. Now, one of the things you have to understand about networking is that networking can be split up in a lot of different ways, but generally the network model is like an ogre or an onion. It has layers. It makes people cry, and it's terrible to look at. And this is kind of how we can identify the information and how it flows and what is important at each aspect of it. So while networking layers isn't something you probably are going to use by thinking about it necessarily, this is something that will help you when you go through troubleshooting steps and you're trying to understand issues in networking or things like that. This is something that you actually do go through when you're doing all that troubleshooting. Like I said, you might not actually that's the data link layer, or this is the application layer. You may not actually go through that thought process, but you're going to rely on those to basically be able to figure out where a problem exists. So to start off with, we're going to use the OSI model. Now there are a few different models out there, but the two big ones that you're ever going to get tested on are called the OSI model and the TCP/IP model. And knowing their differences can help you, but really in a certification course, any sort of educational system, actual college course, they're probably going to pick one or the other, and they're not going to test you on both, unless you have a really fucking sadistic motherfucker who's trying to test you. One certification course I took, and I'm not going to tell you their name because I don't want to get sued by these people. The security certification course I had used both and interchanged them, and honestly, their questions mixed them up, which was really aggravating to me because they had to take that test 3 goddamn times because their questions were bad. But anyways, so network layers and the OSI model is we're going to go over today. We're going to go over the OSI model because it has the most, as far as it's got the most applicability for everybody. And honestly, you're going through a troubleshooting step for networking issues, anything on the internet or really anything having to do with data transfer, you're probably going to end up walking through a lot of the OSI model. Now, again, you may never use this in the real world. Like, you may never actually walk through the OSI model when troubleshooting something. And if you do, I feel sorry for you, but that's another story. Anyways, the OSI model starts out with a lot of different layers. There are 7 layers. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer, in that order from 1 to 7. A lot of people like to rely on mnemonic devices, and I don't know about the efficacy of those, but I can understand some people's reliance on them because 7 layers is a lot to remember, and like I've already forgotten what all 7 of them are without having to look at them regularly. But these are some of the most popular mnemonic devices. All people seem to need data processing. A penguin said that nobody drinks Pepsi. Please do not throw sausage pizza away. People don't need to see Paul Allen. Please do not text stupid people acronyms. And that one's actually kind of my favorite right now. But you can come up with your own mnemonic device if you really want to. Like, pretty dumb naked transvestites serve pizza always. Oh, that's a mnemonic device. Sure, and it's memorable. But, I'm not going to remember that. Like I said, it's difficult to remember all 7. But we're going to try our best. We're going to try our best to understand that there are 7 layers, kind of like a 7-layer dip or Chicago 7 pizza at Old Chicago's or any of that. There's 7 things there. So let's start off by looking at each layer in turn. So to start off with the physical layer, this is responsible for connectivity, just direct connectivity. This is the zeros and ones as they transfer across the medium at which you are connecting to a device. This is typically just the electrical cable. It is responsible for the zeros and ones and zeros, and it is responsible for bit rate control. So bit rate control, your communication has to understand how fast you are sending and receiving data, and your network, your devices have to agree on that. Because if one's sending it at 1,000 and another one is receiving it at 100, you're going to have issues. They're not going to understand what the problem is, what's going on. This is basically, again, this is going to be your network cable. Honestly, this is going to be that in terms of wireless communication. This is going to be the communication between the two NICs, the two wireless NICs, wireless network interface. And so when you are troubleshooting connectivity, you're typically troubleshooting it at the physical layer. Now there's also the data link layer, which is the second layer. Data link layer. You can kind of categorize this or identify this by the MAC address of your device. MAC stands for Media Access Control. And basically this MAC address is the physical address of your device. This is a series of numbers that your device identifies itself to all other devices through. Everything can be identified by a MAC address, and this MAC address is kind of tattooed on the device. And when you're looking at a network map, you can also identify devices by their MAC address because they're assigned by the manufacturer. And certain manufacturers have specific MAC address, they've got MAC address codes that they use, like the first 8 digits of the MAC address code, or not 8 but 6, are a specific device manufacturer and device type. And so a lot of things can happen using that. But also the data link layer, this is where information can be broken up into specific size of information. So when you're sending information, when a device sends information, it's sending it in packets, because you don't want to just start, like me, talking stream of consciousness, because it can be really disruptive and you're not necessarily going to catch all the information. So you break it up into segments that are called packets, but those packets may be too large. And so what we do is we break them into frames. And frames are a very specific series of data. And in this data link layer, basically those frames get sent in order, and ensures that not only are those frames sent and received, but it also makes sure they're sent and received in the exact same order. And if there's an issue with one, or an error in one, that frame can get resent. That's kind of what the data link layer is responsible for. Basically, you can think of this as as a it's really this is kind of the guy on the line or a guy in a relay race that makes sure that the handoff occurs properly, that the information gets handed to the packet properly, or the information gets handed to the next runner properly. Baton. It may be a terrible, terrible idea. Anyways, the network layer is the next one. Network layer is has two main functions. It is breaking up segments into packets and then reassembling the packets on the receiving end. This is also responsible for making sure that devices get an address that can be identified through the rest of the network, and this also is responsible for the route which the information will take. And so this is where we get an address from the network. This is where we get something assigned to us from the network, and this is called the IP address, IP Internet Protocol address. And so if you guys aren't familiar with what an IP address is, basically it's assigned by a series of things, or you can have a self-assigned IP address. But basically, that IP address needs to be identified throughout the rest of the network so everybody else knows what to talk about, or how to talk to that device. And so there's a lot of different ways to explain this, but basically, if you're getting assigned an IP address, meaning that you just plug your device in and it gets an IP address, 90% of networks are probably like this. This is called DHCP, and what DHCP is it can be kind of identified like the phone company. It can be identified like the phone company because DHCP, actually known as Dynamic Host Configuration Protocol, this is the phone company assigning you a phone number. If you have a phone number, then you can communicate out to other people. You can hand people your phone number. People can call you from that phone number, and you can get information. And so as long as you have that phone number, people know where to get that information from. Also, if the phone company decides to change your phone number, people no longer know that's your phone number, and they aren't calling you appropriately. That is kind of how an IP address works and how DHCP works. It's a little more complicated than that, but at a base level, that is how DHCP works. Now, DNS also within the protocol level, or within the network layer, DNS is the host name of the sorry. DNS is the host name. Domain Name Services assigns the IP address to the host name. And so when I have a phone number, that is basically the phone book or the identification that I own that phone number, so people know that Matthew Miniman has this phone number, and they can basically tell Siri, call Matthew Miniman, and then they'll know to call me or Google or whatever. So the network layer, it kind of has all that in there, where information is being identified and by the device name and the device IP address, and then the path across the network is chosen. So to get from point A to point B, this is how I go there, and I can take this route to get there. That's the fastest route I can take to get there. The next layer in the process is called the transport layer. Transport layer takes data transferred and breaks it into the segments for transmission. And this is where data also gets reassembled. And basically when information is sent and received, this is the layer at which information is sort of configured and assembled and can be readily identified. This is where data becomes understandable inside of the network model. And so as data gets sent ones and zeros, and they get broken into, and they get formed into frames, and they get sent and received by the different devices, they can then be reassembled here in the transport layer so that your information is understandable. You can think of this kind of like in a crowded room. This is the communication between two people and knowing that there's information there. If you think about how if you have a conversation in a crowded room or like a bar and there's a bunch of people around you, there's just a lot of shouting. You have to know that somebody's talking to you, and you have to pay attention to them. And that's what the transport layer essentially is. It's that understanding. It's the ability for your brain to understand that there's all this other information coming out at you, but the information that's coming from this one person is this conversation that you're having with them. Don't know if that makes any sense, but that's how the transport layer kind of identifies to me. Moving on, layer 5, session layer. Session layer is where we identify a communication stream between two devices or two IP addresses or whatever. This is where we'll use Netflix as an example, because this is kind of how this goes. When you have a session open with Netflix, one of the things that happens is you are downloading all of their data in a stream. And as you download a movie, Netflix will have your progress. And so if you pause your movie or show at a specific point, Netflix knows you've paused it there. And so you can resume your session at that point. However, if for whatever reason, Netflix sends you data and then can never verify that you've actually received it or that you've watched past a certain point, you may get what happens occasionally, in that Netflix will identify that you've watched up to a certain point, but then for whatever reason, it never sees you continue that movie on. And that can often happen when, like, you watch a movie, all of a sudden you lose connectivity, and then you've watched, the next 5 minutes of the show that you've downloaded, and then the session has ended, and you can't reestablish it, and it goes, oh, there's an error occurred, and your Netflix dies, and then you try to go back to it, and you see that Netflix doesn't watch that 5 minutes, and so when you go back to the movie, you have to rewatch that 5 minutes or skip through it. That's kind of what the session layer handles. That's how it handles it exactly, is that when you're transferring data, you transfer it in a stream, and you try to keep the session alive so that way both sides can monitor the progress of the transfer and allow you to resume it should something happen to that session. Also, the session layer can identify the data by making sure that the checkpoints that both sides agree on are met. And so this is also where communication is set, meaning when you are establishing a connection or have established a connection to another device or another organization, this tracks both whether it's connected or not, but also tracks the time frame of the connection. So how long the connection existed, because it's important for both computers to know exactly at what point in time or how long the connection has lasted, because that needs to be in sync on both sides, because one thinks it's been connected for 15 minutes, another one thinks it's been connected for 5 minutes. You can have issues with the transfer of data, because one might request the information from 10 minutes ago thinking that it was connected only 5 minutes. So that's what's important on the session layer. And so moving on to the next one, layer 6, almost done. Presentation layer. This is where encryption, compression, and translation happen. This is where the data is prepared. This can also be identified by the protocol that you connect over. So SSH, HTTP, HTTPS, SNMTP. There are tons of protocols, and I'm not going to go through all their fucking acronyms in this one. I've already bored you guys enough with my terrible explanation of all of this. But the identification of the information is that in layer 6, this is essentially how you are communicating and how secure your communication is. In layer 6, you encrypt your information on the sender's end and then decode it on the receiver's end. You also compress it at this point. If you are compressing the data, this is where you would compress it. And this is how you would translate the data appropriately based on the information that you're using. And so if you are having issues with communication, you may not be using the right protocol. So for instance, there you can communicate over HTTP and you can communicate over HTTPS, which one is encrypted and one isn't. And so if you are attempting to communicate to a HTTPS website, but you navigate to it through HTTP, you'll receive an error. Now, generally, most websites handle this by actually having a redirect so that it forces you over to the HTTPS website, but some don't. And oftentimes, actually, if you try to access like your router has an internal HTTPS server. And so if you attempt to access it over port 80, which is HTTP, you'll get this error that says you're trying to communicate to an HTTP source through an HTTPS port, or HTTPS source through an HTTP port, and it will tell you to fuck off because you're not communicating to it properly. You're not using the proper the proper connection or present. You're not presenting the data appropriately to the device, and the device can't present the data appropriately to you. And so that's kind of how all of this information will flow across. Now, when we go and do another deep dive, we'll actually go through the acronym of all of these fucking ports and all of these protocols. We'll go through all of them, and I promise you that will probably be no more exciting than this one is. But just know that the presentation layer does identify the way you're presenting the data by how you're connecting to the device, how you're presenting it. And then from there, layer 7, the last layer, is the application layer. This is also known as the user layer. This is where the information is presented to you as the consumer of the information. This is where your web browser acts. This is how your web browser sees the information. This is also the layer at which your video games will communicate to each other. Application, it kind of is in the name, right? This is how these different devices initiate communication. And so the important part about the application layer is this is where you actually interact with the data as an individual. Typically, you aren't interacting with the data at any other layer other than this one directly. So those are the 7 fucking layers. Again, starting from layer 1 up to layer 7, it is physical layer, data link layer, networking layer, transport layer, session layer, presentation layer, and application layer. If you're going to take a certification course or certification test and you're doing networking, I feel bad for you, son, but yeah, these are the 7 layers. This is going to be your world in that. And like I said, we will cover the actual layers, a lot of other protocols and other networking information as we walk through other networking deep dives. And so I wanted to leave you with the last thing on this is that the OSI model kind of is the end all be all of networking structure and how information flows. If you want information on this, Cloudflare has a lot of really good articles on this. There are also a ton of other organizations that have articles on this. I know I don't like to push specific products or lines to you guys, but I did find a lot of really useful information on CBT Nuggets. CBT Nuggets does this very well. And so if you guys want a better explanation with visuals, that's probably going to be one of the better sources to view it from. CBT Nuggets does a great job with that. I know that, and this is an audio only format, so presenting this information to you graphically is not really an option for me, but know that this is something that can kind of be seen over a visual format as well, and it can help. So if you're a visual learner, go check one of those out. Otherwise, Yeah, this is that's the network. That's how your network communicates, and that is all of the layers. To understand somehow this came to be, we can go back and look at how serial connectivity used to work and how the old networking was. Because way back fucking when before there was internet and before computers regularly communicated to each other just by plugging a single cable in, we had things like parallel connections and serial connections. All of these layers and communication paths seem really complicated and complex, but one of the things you should remember is that this stems from the original serial connectivity, the parallel connectivity, where you had to manually control things like communication flow, bitrate control, error control, and you had to do all of these things kind of manually. And with the modern implementation of networking, we kind of have the computers do all of that orientation themselves. They don't actually have to rely on human interaction to make that connection. And so, if you think about it, this is kind of the first step into the AI end of time that everybody has been progressing. It was like back in 1980 when TCP/IP, or 1976 or whenever, when TCP/IP was first introduced. That was kind of the first stepping stone into the machine takeover. You can blame those guys. So if we ever have a Terminator, it's because they decided that they didn't want to have to configure error control or flow rate control on their devices anymore. So, anyways, I hope that wasn't too boring for you guys. I hope you guys found value in this. Again, we'll go into more network deep dives later and hopefully cover more interesting topics in those networking deep dives. But this was the OSI layer as our first networking deep dive. I hope you guys have a great day.